Hi, I'm Karl at Escape Trailer, where we build for you with more customization and personalization than any other travel trailer manufacturer in North America and, dare I say, in the world. If you find this content useful to you, please like and subscribe. We develop this content specifically for our customers because we are direct to consumer. We do not have dealers. And for us, it really is all about giving you the maximum amount of information so that you can educate yourself and then make your choice as to whether or not you want to have a truly customized and personalized trailer built just for you. One of the key aspects of owning a travel trailer, and specifically trying to get out into the world or into nature, is understanding the power systems and understanding the energy that you have in your trailer and how to manage that energy. So we put together a little video here. This is a refresh on a video we did a year ago, and we'll have the link down below for that. And this video will really try and educate you on how power comes into your trailer, or how you acquire energy, how you then store that energy, and how that energy gets used inside your trailer. And you know, it can be a little bit complex, so we try to boil it down as much as possible, but keeping some of that technical content, which is obviously very important. I'm going to do one very quick summary. So we have three different types of power input into the trailer. The first one is a plug, and this will be at your campsite. That's going to give you 120 volts AC. The 120 volts AC runs straight through to your power converter and distribution center. The power converter takes the 120, converts it to 12, and then the distribution will allow 120 to flow through and the converted 120 to 12 volt DC to run through. Inside your trailer, you have a combination of appliances that will run only on 120, and then appliances that will run 120 and or 12 volt DC. So this feeds everything inside your trailer. Second option, I'm not plugged in at a campsite somewhere. I need to run off the power that's in my batteries. We have your solar panels. That's the input on the power. It's a variable voltage which goes to the solar charge controller. The solar charge controller will regulate and push 12 volt DC out into your batteries. Remember, solar only ever charges your batteries. It'll go to the batteries. From the batteries, the 12 volts will come back up into the distribution center, and then you'll only have 12 volts coming out to the items or appliances that run on 12 volts. Your vehicle is another way of charging, and it does almost exactly the same thing. The vehicle will give 12 volts DC in. That will then go straight to lead acid batteries or through the DC to DC charger for a little boost, and also protecting the alternator on your vehicle. That will then go into the batteries, let's just say. We have a Victron smart battery monitor, so you can always see how many hours are left running, your running condition based on the state of charge in your batteries and what you're using inside the trailer. The energy from the batteries at 12 volts then runs up into the power distribution center and into the items that are 12 volt DC. If you wanted 120 volts AC inside your trailer while you're boondocking, you need an inverter. The inverter will take power from the batteries. It'll convert it from 12 volt DC to 120 volts AC. That will feed directly to the outlets. The inverter only feeds the outlets inside your trailer. So now you can have the outlets inside your trailer run 120 volts AC, but you still have power from the batteries coming through, giving you 12 volt DC to everything else inside the trailer. So that's a very quick summary explanation. Okay, so we're going to run through this. As you can see here, we have a whiteboard, so we're back to school days. We also have a lot of equipment laid all over the table here. So we're going to work sort of back and forwards between the whiteboard and the equipment that we have on the table. I think it's really good for you to sort of see it from all different angles. And we're also even going to jump into a trailer so we can start to see what it looks like inside an Escape trailer, just to put just a little bit more education into the whole process. So I'm going to start at the very beginning. Inputs. What are all the different ways that you can get energy into essentially the batteries or into your trailer? We're going to look at three main types. We'll start off with the first one. So in the beginning, we have what we call, or a lot of people call, Shorepower. For shore, the idea being on the side of the sea somewhere, or the side of a lake maybe, comes from the marine industry. So we like to call it campsite power as well. So you have campsite power. You can also power from a generator and your house. There are some considerations. That's why I have a little bubble here with question mark and exclamation mark. There are some considerations when you're doing something powering a trailer from your house, and it's all to do with amperage that you have. So typically you need a 30 amp for everything to work very successfully. So that's what we call shore power, plugged in at the campsite or plugged in somewhere else. The next one is solar panels. Of course, everyone knows what solar panels are these days, and what solar panels do is they take the energy from the sun and then convert it into electricity, which can then be used to charge your batteries. And really, that is all the solar panels do. They just charge the batteries. And we'll talk a bit more when we go through that, how they charge the batteries and the tools or the equipment that's in place in order to do that. The last one then is your vehicle. So on the back of your vehicle, you will have a 7-pin connector, or you need to have a 7-pin connector, certainly for the escape trailers, because you need to power your brakes. But through that 7-pin connector, your vehicle's alternator, which also charges the battery in your truck or your car, will send power back into your trailer. Of course, it does for the lights and for the brakes, but at the same time, we can use that power to charge the batteries inside your trailer. Okay, so those are the 3 ways that we can do this. Let's go back to the beginning. So shore power or campsite power, you would plug in your plug. Okay, so this is a removable power cord. That's an option in the escape trailer. There is also a standard power cord, but this one's removable because it's got a removable end, which sort of stops any bugs from getting into your trailer. You have the choice to choose this. So this is a 30 amp plug that's on here. You see it looks a little bit different to a standard plug in your house. So you'll plug this into your campsite, and then the other end goes into your trailer. We also have an adapter. So let's just say you're at home and you want to plug into a normal outlet. So we have an adapter which sort of slides onto here, and then that will plug in at your home, so for your house. Now, I'm not going to go through all the details on using this at your house, but it should suffice to say that your house is typically a 15 amp supply, and to run everything successfully, you need a 30 amp supply. There are things you can do. You can sort of switch things off and then be able to run off your 15 amp if you're using, say, your trailer as a guest house, which is quite common, or even a refuge spot, which people have done a lot in the past with their escape trailer. Okay, so that's how you get power into your trailer on the shore side. Now I'm going to talk about batteries. So we talked about how to get the power into your trailer. Now I'm going to quickly talk about batteries, because there's a lot of confusion about the difference between lead-acid batteries and lithium batteries. And we all hear about lithium because of electric cars and the like these days. So let's just go through a little bit of the differences. Standard in the escape trailer will be a single 12-volt battery, and that 12-volt battery is sufficient to power all the 12-volt systems that are inside your trailer. So it comes standard with a 12-volt battery. There is the option to upgrade to 2 6-volt batteries, which will give you more energy. We'll talk a little bit about that later on when we talk about the capacity of these batteries. Both of these batteries here are what we call our lead-acid batteries. Lead-acid batteries look a lot like this. Okay, this is the 12-volt battery, and here are the 6-volt batteries. Then we have lithium batteries. Now, lithium iron phosphate is probably the full description for these batteries. People tend to call them lithium phosphate. So we're just going to abbreviate for the moment. You could even go back and just say, these are just lithium batteries. Lithium batteries look like these. Well, ours do anyway. There are various types of lithium batteries, but these are ours. Lithium batteries are a lot lighter than lead-acid batteries. And one of the key features of lithium batteries, well, there's 2 real great points with lithium batteries. First one is they are a lot lighter. Secondly, they require no maintenance at all. So lead-acid batteries need to be maintained and refilled with distilled water from time to time. Lithium batteries, 0 maintenance. There are a host of other benefits with lithium batteries, and we list all of those on our website, but they discharge better, they can discharge more, they have a longer life. Just in general, lithium batteries are going to replace lead-acid batteries over the next number of years. So these are your battery types. In the escape trailer, you can have 1 12-volt, you can have 2 6-volt batteries, or you can have up to 4 12-volt lithium batteries. And as I said, we'll go through all the amp hours and the energy storage in a little bit. Let's work our way back now. Let's go talk about how power sort of flows through from each of these systems into your trailer and what it powers for you. I mean, at the end of the day, all you're interested in is, I need power for my fridge and my outlets and maybe my air conditioner and the lights and the sockets and stuff in my trailer, or the power points in my trailer. I just need that power. But the question is, where does it come from? And depending on whether you're boondocking or you're on a campsite, you may have some limitations with it. So let's work our way through this. If we're on the first one, Shorepower, we're plugged in to the campsite or to a house or to a generator somewhere, we have what's called AC power. So 120 volts AC. 120 volts AC coming in. That power will run straight through into an item called the power converter and power distribution center. So we have a combined one here. And what this does is two things. It takes your 120 volts and it will then distribute it to the different systems inside your trailer. What it will also do is it'll step down, or it'll change the 120 volts AC into 12 volts DC. So there's alternating current and direct current. They are different to each other. So this will take 120 volts and it can also convert it to 12 volts DC. From this power converter and distribution center, then we send 120 volts AC out to appliances that use 120 volts AC. And we also send it out to appliances or items that use 12 volt DC. In travel trailers, often the appliances can use both 12 volts and 120 volts. And indeed, in the case of fridges in trailers, and this is changing a little bit, and you can have ones that specifically stand alone, but in general, fridges operate up to a maximum of 3 ways. The first way being they'll operate directly off 120 volts AC. They will also operate off propane. So this is an absorption refrigerator. And then they'll also operate off 12 volts DC. The last one is not advisable, and it's the only thing, you would only do it in an absolute pinch, because they draw a tremendous amount of current and they will pull batteries, regardless of what they are. They'll pull them all down really, really fast. So that's like the maximum is you'll have a 3-way fridge. And a lot of manufacturers now are actually just going to 2-way fridges, which is a 120 volt AC and propane sort of fueled fridges for you. So that's an example. You know, the slight difference between RVs or maybe even marine RVs, boats, and your standard residential is, in residential, pretty much everything is 120 volts AC, whereas in travel trailers, you can have this mixture. That's why you got this mixture of power, and that's why it's important for you to sort of understand that there are different voltages and different types of power inside the trailer. The 12 volt DC will feed things like, you can have a 12 volt outlet. You can have your lights. You know, most lights these days in travel trailers are LEDs and they all run off DC. So that will run the lights. And then there's a certain amount of appliances that run directly off 12 volts DC. So the fans, like we use max fans on the roof of the trailer, they'll run straight off 12 volt DC. We said the fridge, at a pinch, wouldn't like to do it. The ignition in the cooktops that we have, 12 volt DC. The heater, remember we're a Canadian company, every trailer comes with a heater, everyone should be able to stay warm. And the heater, the fan in that heater runs off 12 volts DC. And then there are a bunch of other things, but we'll leave it at that for the moment. So if I say 120 volts AC is what you get when you plug in, it runs straight through to the power converter. The power converter will pump 120 volts AC to the appliances that need it, and 12 volts DC to the items or appliances that need it. And it's simple. You're plugged in, everything just works, which is really nice. Then we have solar panels, the idea of solar panels. Solar panels, like I said, only charge batteries. And then the batteries feed into the power systems in the trailer, or feed into the items and appliances that you have in the trailer. But how does that work is always the question. Well, solar panels, they just absorb energy. And of course, the sun moves, clouds come in, it moves around, which means you don't have constant energy from solar panels all day long, nor do you have constant voltage coming out of them. So there's a variable voltage that comes from the solar panel itself. For us, on the roof of the trailer, we install what we call an MC4 connector. Let's just say this is on the roof of the trailer, an MC4 connector. The connector is then connected to the solar panel. Here's an example of a rigid solar panel. And these are the ones that we install on the roof of the Escape trailer. They're very robust solar panels. So we will connect this solar panel to the MC4, and then the MC4 connector, just sort of around here somewhere, connects to what we call a solar controller or charge controller. Maybe it's a better way of saying it. So this is a charge controller. So you can imagine this connects into this. Okay. And then the solar charge controller is connected to the batteries, right? Whichever type of batteries we have. It doesn't matter whether they're lead acid or lithium. This is tolerant for both. And the solar charge controller monitors the state of the batteries and then determines how much charge or how much voltage it's going to put in to those batteries. So this is variable. This is the controller, the charge controller, and it controls the charge that goes into the batteries. This is the really important piece of equipment. Now, there are other ways or other types of solar panels, and you may have seen we have one on the floor here. So this is an example of a portable solar panel. This is from a company called Lightleaf. It's a very nice panel. You need to be very mindful of something. The voltage coming out of these panels, you need to have a portable solar panel that gives out the same type of voltage, right, or the same amount of voltage, because when it goes through the system into the charge controller, what will happen is if you have a mixture of solar panels and this one is rated lower, then the entire system will derate. Now, in order to connect this to your trailer, we install what we call, or what is called it's like a solar port. This one is from a company called Zamp. There are different ones. There's an SAE solar port, and then there's Zamp. Main thing on this is if you're going to use a Zamp, then you need to use a Zamp portable solar panel, or I know there's a kit you can get that reverses the polarity. This is a reverse polarity solar port for Zamp, but for very good reasons too. But just to give you an example, there is another way to connect up more solar capacity to your system. So that's solar panels. They do a variable voltage, goes through the solar charge controller, and that solar charge controller will charge the batteries. This solar charge controller, as I have here in blue, is Bluetoothed to your phone. So if you really want to know what's happening, like on a minute-to-minute basis, in terms of charging to your batteries, you have all of that capability through the app that they have on the phone. This is a Victron MPPT 100/20 that we're currently using, and it does give fantastic information. We'll try and plug that into this video a little bit later, or we'll do another video after this, which kind of takes you through a lot of those details. Okay, next, the last one is the vehicle. So the vehicle that you have plugs in to the trailer, and this is an example of the pin, right? So the 7-pin will be on your vehicle, right? The receiver side. So this will plug into this is into our trailer, and this plugs into your vehicle, and this is what sends power back to your trailer and also back to your batteries. Now, the vehicle is sending 12 volts DC, and that 12 volts DC will then feed back into either of the battery systems, whether it's lead acid or lithium. Point to remember, alternators on vehicles are typically paired or set up to run with lead acid batteries. So if you have 12 volt and you have lead acid batteries inside your trailer, then it knows that system, so it's not an issue. It'll push straight back. If you have lithium batteries in your trailer, then you're well advised, and we automatically put this in as part of the solution, to use the DC to DC charger. Okay, so the DC to DC charger looks like this. And principally what this does is it protects your alternator, right? Because the charging profile on lithium batteries is quite different. So this does two things. It kind of boosts the power, but it also protects your alternator. So this is a very important piece of equipment to have in your system when you're using lithium batteries in your trailer. Okay, so that's how that system works. So it's the same, very, very similar to the solar panels in that it pushes out DC current, and the DC runs straight through the solar controller or through the DC charger into the lithium batteries, or direct into the lead acid batteries in your trailer. Okay, I'm going to stop there for just 1 second. Now let's look at how that power comes from the batteries and moves through into the outlets and systems in your trailer. And I'll talk about this at the same time. So I'm in my trailer. If I'm plugged in 120 volts AC, I don't worry about batteries. It's easy. It goes through the power converter and goes off to all my appliances. And also, when I'm plugged into Shorepower, the power converter feeds back into my batteries to charge my batteries, because remember, it can push out 12 volts DC. So the power distribution center will feed. So if I'm on shore power or campsite power, it'll feed back in and it'll charge my batteries regardless of the type of battery that I have. Otherwise, I have my batteries. My batteries, let's just say it's my either system, whether it's lead acid or lithium, they will deliver 12 volts. They'll only deliver 12 volts DC out. 12 volts DC will come up into my power distribution, right? So this time the converter part is not working because it's 12 volts coming in, not 120. So that will put 12 volts in, and that 12 volts will then be distributed to all the outlets and appliances that I have. So your batteries will feed 12 volts. So anything in your trailer that's 120 volt only will not be powered. It is coming purely from the batteries. Okay. Typically, you're at a campsite or you're boondocking and you're worried about how much energy do I have left? How long am I going to be able to stay at this campsite if, say, we're completely clouded over and it's the middle of, or very dark for whatever reason, I don't have any way of charging. So what we've installed on any solar system that you have is a shunt and the Victron Smart Battery Monitor. The Smart Battery Monitor looks like this, and this item here really is the shunt, and then these are a couple of fuse boxes that we have in place. So this connects to the battery. I'm not going to say this one because typically if you get solar, you do not take the 12 volt. You must move up to one of these solutions. So we will feed with solar from here, connects to the terminals here. These terminals then are output to the Victron Smart Battery Monitor, and we'll show you some more details about what this tells you. But principally, and my wife likes it because you can just look at it and say, we've got 3 hours left on batteries before we need to recharge in some way, assuming, say, the solar is not working. So very handy just to say, based on my current usage, this is how much I've got left. And let's just say you're in full sun and you're not using that much power. It'll actually be the opposite way. It'll say, oh, you've got so much, you're actually in a negative condition, which means you've got more charge and less current draw in your trailer. So this is a very handy tool for everybody to see exactly what they have in their batteries, so how many hours they have left based on their current consumption. Okay, so that's the battery monitor. The next question that we get is, is there a way for me to get my outlets powered so that I have 120 volts inside my trailer while I'm boondocking? So it's like, I'd like to have my cake and eat it at the same time if possible. And that's where a thing called an inverter comes in. So the inverter is kind of the opposite of the converter. So the converter takes 120 volts AC, turns it into 12 volts DC. The inverter takes 12 volts DC and upconverts it to 120 volts AC. So we can take your batteries, route them through an inverter, which is an option, and the inverter kind of looks like this. And there are various types of inverter. Just happens to be one we have on the table right now. This is a 1500 watt inverter. So the batteries will feed the inverter. The inverter will convert 12 volts up to 120 volts AC, and then that 120 volts will come and run to your outlets only, right? It won't power any other items. It really only goes to the outlets. And of course, you still have your 12 volts coming and feeding the rest of the items inside your trailer. So that's how you get your outlets powered at 120 volts by using the batteries while you're boondocking at a campsite somewhere. Okay. A couple of points I forgot to mention. So let's just say we're talking about the outlets in your trailer. So this is your 120 volt outlet. So it should be quite familiar to everybody. This is what you have in your house. And here's an example of a 12 volt outlet. And you'll see these are still in cars. So this 12 volt. This one happens to have a couple of USBs on it as well. And a lot of these are optional inside the trailer. There are standard locations inside the Escape trailer for these, and then we have lots of optional locations. As I said, we customize and personalize more than any other travel trailer manufacturer in North America. Another nice thing that we do at Escape is we have our own custom-made battery box, and this battery box, of course, stores your batteries. So this is a custom-made one, of course, for customers in the USA. The regulations are that lithium does not need a storage box. Of course, in Canada, we still need a storage box for any battery, regardless. Storage box is handy because it just kind of keeps the batteries in their own little space and protects the terminals and connections that are on there. So this comes with every trailer as well. Now, the next question that we get is, well, Karl, I need to have some estimation of how much power storage I need. The lithium batteries are not cheap. Do I need 1, 2, or 4? We do 1, 2, and 4. We don't do the third, just because we're trying to balance these batteries. They have such low resistance that we want. I mean, it's very important to make sure that you try and drain them all equally. So we do a 1, 2, and 4 setup, and we avoid the three setup, just because it's very complicated from a wiring length perspective. So how much do I really need? This is a very complicated question to answer because I don't know how much you're going to use. And the really only way to do it is to maybe run some profiles for yourself in your trailer and say, oh, okay, when I'm out camping in the desert, I'm going to sort of have my fridge probably working a little bit harder than normal because it's going to be a little bit warmer. Plus, I'm going to run my lights at whatever time, or I've got a CPAP machine going or something. So it's challenging because you have to try and calculate how many amps you need. So it's difficult for us to do, and we kind of give you an example, or at least give you some lesson on the calculations that you would need to do in order to calculate what you believe you need. But here's an interesting example. We did this before on the last video, where we looked at something essential like heating, right? And this really came after the southern states had a seriously cold blast, and they weren't set up for it, and a whole lot of people were without power in their houses, so they resorted to going to their trailers. And we were like, yes, that's really important, right? When it gets really, really cold and your part of the country is not necessarily set up for it, then retreating to your trailer as your escape is very important. So we've done that. So I would say go back to that video and you'll be able to see how many hours you can get purely just keeping your trailer warm, assuming, of course, you have sufficient propane, which is kind of easier to store generally. So in terms of batteries, some little bit of technical information here. So an AH, you'll see this a lot, it refers to what's called an amp hour. Okay, and amps are usually the current that comes through. So 1 amp hour is equal to a one amp light that's running for 1 hour. That's what that really talks about, 1 amp hour. So then if you take an amp hour and you divide it by the number of amps that your equipment draws, it'll tell you how many hours you'll be able to run on it. So this is the calculation that we use when we go through here. The example that we've chosen is a compressor fridge. Compressor fridges are different to, obviously, the absorption refrigerators. And the compressor fridge is typically what you'll have in your residential property. And the compressor fridge is a very efficient appliance which runs purely on 12 volt DC. So a compressor fridge in a trailer runs 12 volt DC and runs very efficiently on 12 volt DC. Now, the advent of all this lithium storage has made it that people are able to have compressor fridges inside their travel trailers and have those compressor fridges run for longer duration periods. Compressor fridge is more efficient. It cools better. It cools faster. So, but you kind of got to have energy storage to be able to support it. So if you're going down that road anyway, then compressor fridge is a very nice option to have. So we just said compressor fridge here, and the one that we provide runs 3.4 amps peak. So that's just saying it's kind of redlining all the way, which means, we all know, like a fridge doesn't always redline, right? It gets the temperature and then it kind of shuts off. Then it comes back on again when it needs to. So this might be the worst case example. Batteries. We have your standard 12 volt lead acid battery. Remember, it needs maintenance. But another important factor with batteries is, although this standard 12 volt lead acid battery is rated at 88 amp hours, you never want to take a lead acid battery down below 50% of its available capacity. And the reason for that is that they're not tolerant of high discharge. And it can actually damage the battery. It can damage the battery such that it won't recharge again very well. Now, there's some tolerance within that, but in general, we say, or the industry says, 50%, take it down to 50%, charge it back up. Take it down to 50%, charge it back up. So using that 50%, we say, you've got about 44 amp hours that are actually usable if you want to maintain this battery. So that it's not like just toast, the first couple of times you've used it. And I'll give you approximately 13 hours. So if you take the 44 divided by 3.4, you get somewhere around 13 hours. So run that calculation through everything else. You have your 6 volt lead acids, 225 amp hours is what 2 of those will have. Same rule applies, being a lead acid, so you take 50%, so 110 amp hours. That gives you about 32 hours of running on it. And then when we get to the lithium batteries, things start to change a little bit. And that's why I have a couple of different notes here. So let's just say in this option, you have your lithium iron phosphate battery, and you have a single one. Well, a single lithium iron phosphate battery is 100 amp hours, right? Is 100 amp hours. And that 100 amp hours is actually usable. Now, little nuance here. You can discharge a lithium battery all the way down and bring it back up. It's recommended that you only take it down to 30%, right? So you derate it just a little bit. And that is to extend the overall life of the battery. So it's not going to create the same damage to the battery that it would if you took a lead acid battery all the way down, but it potentially shortens its life over time. And life is significantly longer than a lead acid battery. So just to keep apples to apples comparison, I said, if it's 100 amp hours, it is 100 amp hours usable when we're apples to apples comparison with the lead acid batteries. But our recommendation is you run it at 70, you assume 70 amp hours. And indeed, when we set the system up before you receive your trailer, we go into the software and we set it at 70 amps. So it's never going to take it all the way down. It's going to shut off essentially when it gets down to the essentially what's 30 amps. Okay, you, of course, through the software, through your Bluetooth system that I talked about earlier, have the capability to go and change that yourself to be whatever you want it to be. So we'll just kind of set it what we recommend, and then obviously you can take the responsibility of doing that afterwards yourself. After all, it is your trailer. You decide what you want to do with it. If it's 70 amp hours recommended, you're going to get 20 hours out of a single lithium battery. If you were to go up to the 100 amp hours, maybe say at a pinch, then you'd get 29 hours out of it. And then as we roll through, oops, I missed one. Second battery. There we go. That's done. So remember I said 1, 2, and 4. So if you had a second battery, okay, double everything up, and then you get to have them 40 hours or 58. And then when you get your 4 batteries in place, potentially have 400 hours, and you can have 80 hours or 117 hours available. And now I know this doesn't solve all your questions with respect to how many do I really need. The one thing I would say is this, that a lot of our customers now, if they can afford it, are just taking the 4 batteries and saying, now I know I've got the maximum energy storage that I can have in the trailer, and I'm good. I'm generally good with that moving forwards. And these things will last an incredibly long time as well for you. So there'll be a part 2 to this video. We have a trailer set up outside that we have been running for a number of days. So it has gone through some charge and discharge and charge and discharge. We'll have a quick look at that trailer and we actually take you physically through the system so you get to see not only what it looks like inside the beautiful Escape trailer, but also maybe a better sort of visual representation of what the data output looks like. So there you go, folks. I hope this information has been really useful to you. Please like and subscribe. We develop a lot of content like this, which is somewhat agnostic to Escape trailers. So really just talking about systems and technology in the RV space. Hope you enjoyed it. Don't forget to like and subscribe. I'm Karl at Escape Trailer. Remember, we're built for you.